Dear participants, a very good evening to all of you. Now today we have come for the day 4, session 7, and I know this is one of the session all we are looking forward to. So we have the Vaibhav Singhal sir. So we are happy to extend a warm welcome to Vaibhav Singhal sir, who is the associate professor in the Department of Civil and Environmental Engineering at IIT Patna. Sir did his PhD from IIT Kanpur and specializes in structural engineering with a primary research focus on seismic behavior of reinforced concrete and masonry structures, small-scale modeling of structure system for real-time dynamic testing, seismic evaluation and rehabilitation of structures, earthquake damage service and disaster mitigation and preparedness, and many more in the structural engineering field he has covered. So he was ranked first and a gold medalist from Aligarh Muslim University for his BTech and diploma in civil engineering. Sir has contributed significantly to practical standards, drafting the IS 17848-2022 on confined masonry for earthquake resistance. Also, Sir was involved in the preparation of the technical report of the magnitude 6.9 Sikkim Nepal border earthquake of September 18, 2011 in Earthquake Engineering Research Institute that we know that as a EERI. So, Sir has published over 48 research publications, 65 conferences, and achieved over 1,600 citations. He has strong publication record in top tier journals and leads in active research group at IIT Patna. He has received awards including recognition of innovative projects from the Indian National Academy of Engineering. Currently, he is working on a project on the study of construction methodology and composition of brick and mortar used in the masonry of Nalanda Mahavir, and probably we'll look forward, sir, for in future if you sir can take one session on this. So, sir, thank you for accepting our invitation. We are pleased to welcome you, sir, and would like to appreciate your sir valuable time.
Thank you. Thank you for such a detailed introduction. I think you have done a great research on my profile from somewhere. It is good.
Knowing you, sir, it is almost from 2016, probably 15. I know all of your works.
Great. Let me share my screen.
Yeah.
Okay.
Yes, the screen is visible.
Yes, so the screen is coming in the full slide mode.
Yes, sir.
Okay, great.
Mode. Over to you, sir. Yeah.
Okay. So thank you, Dr. Sushant, Dr. Sushant Banerjee for inviting and for a detailed introduction, and I welcome all participants for this session. So today I will be speaking about evaluation of old masonry buildings, and will try to cover both experimental and numerical approach, what you can do and how you can evaluate the masonry buildings for further assessment, for retrofitting or for their rehabilitation. So see, I will be starting more with the heritage structures. You know that in India, in adjoining countries like Nepal and many other neighboring countries, so we are quite fortunate that we have good heritage, good cultural sites where we can go and we can see and learn about the masonry construction in India or in the ancient time. So this is one photograph after the Nepal earthquake, and especially in the Nepal, in the Kathmandu, there are a lot of heritage structures in southern part of India. In the northern part of India, you see there are a lot of heritage structures all throughout India and many neighboring countries. So why this seismic evaluation or the assessment of masonry has gained importance, and why it is important for us being an engineer or being a researcher. So if you know about the recent earthquake, it is not recent, but I can say the recent, which is known to be a mega earthquake or a major earthquake, which happened on India-Nepal border, which is the epicenter was in Nepal. So during this earthquake, if you will see, this is the bird eye view of a Kathmandu Darbar Square. So which have lot of heritage site, temples, lot of places, lot of monuments, and this is what has happened after the earthquake. So you can see that many buildings were partially collapsed, and the buildings which are in this pink square box, they have been completely collapsed, and where the blue one have been partially collapsed. So these kind of a scenarios were everywhere, which has been seen in Nepal after this 2015 earthquake. So these are the photographs which you might have seen also in the newspapers. So this is the Dharara Tower before the earthquake. This is after the earthquake. And many temple, many monuments, many heritage buildings, they have experienced complete collapse. So this is one of the picture, one of the temple before earthquake. This is after the earthquake. So you can see that how earthquake can lead or completely change the cultural heritage of our country or any place. So it become quite important that we should evaluate, we should see that whether our masonry structures are capable of resisting the future earthquake forces or not, and what level of strengthening or rehabilitation is needed for these kind of structures. So coming to the evaluation, so evaluation of masonry structure particularly is not an easy task. So any evaluation has two different parameters which need to be find out is the demand and capacity. Now finding out the demand is, you can say, straightforward. One can do it easily following the various codes. You can use either your design codes or you can use the seismic codes to find out that how much the demand or how much the force will come in the future earthquake event or in the future loading scenarios. And one can find out the requirement. One can find out the force or the demand requirement. The challenge what happens or the challenging task is to find out the capacity of existing structures, especially the masonry structures. So this is a big question, that how we can find out the capacity of a masonry structure. So any evaluation process and if you talk about a masonry or if you talk about a frame structure, so there are two basic steps. I hope some of you might know about it. That one is the preliminary evaluation. So preliminary evaluation primarily which consists of your site visit, data collection, configuration check, and there are some acceptability criteria. I will not go into detail of that. I will give some brief about that. And then if it satisfies those acceptability criteria, you can say that retrofitting is not required. And if it does not satisfy the acceptable criteria, then one has to go with the detail evaluation, find out the strength requirement, find out do the detailed testing, non-destructive, destructive testing, do some kind of a modeling, numerical analysis, and then do a proper check for a demand, capacity in the demand. So, and then based on that, one can find out the acceptability criteria, whether it is satisfied or not. If the retrofitting, uh, if criteria is satisfied, then again retrofitting is not required. But if it is not satisfied, then one has to go with the recommend or find out how much is the retrofitting, how much retrofitting will be required. So a preliminary evaluation, as you know, it will be a quick and approximate procedure to find out what is the potential risk of a building. It primarily involves to know about the physical condition, robustness, structural integrity, and the strength of a structure based on some simple calculations. Okay. So what are these simple calculations which one can do? So this is as per IS 15988, so which says that you find out that how much is the total area of a wall in a particular direction which you want to consider. Either you take horizontal X or horizontal Y direction. And then this is the demand which you will calculate from using IS 1893 or some other code or a seismic code, and take a ratio of these. And if this value, the stress comes less than 0.1 MPa, then one can say that I have sufficient number of masonry walls which can register the future earthquake forces or the earthquake demand which may come during any seismic event. So this is a basic simple thumb rule which an engineer can use. Of course, one has to first of all also do some visual inspection. There are some visual checks are there which can be used to check whether those are satisfied or not. But this is one of the simple calculation which says that if the shear stresses or the shear demand over the building, if it comes less than zero point 0.1 MPa, you can assume that building will be fairly safe and it can resist the forces during the seismic event. So that is a very crude or very simple check. Now the question comes when we are talking for a detailed evaluation, that how we can do a detailed evaluation of any building, specifically the masonry building. So a detailed evaluation starts with the collection of material, then determining the basic and physical mechanical properties of old material, determining the composition if it is required of mortar. So for that one can do different tests. There are some advanced testing techniques available, acid digestion or the SEM analysis. And also those mortars can be used to recreate the masonry in the lab. So generally for the masonry, finding out the strength is not easy. Like one cannot do a rebound hammer or a UPV on a masonry structure. Uh, to find out the strength parameter like we do for a concrete. So for a masonry structure, there are some different tests. I will show you some of the tests which can be done at the site. If those are not possible, then one can also do a reverse engineering, try to find out the composition of a raw material used in that masonry and recreate it in the lab, and then uh, find out various properties. And in some cases, one can also perform in situ and then confirm the properties which are obtained from the labs are matching with the in situ properties or not. And after that, then performing the analysis, and then you can select the suitable and efficient strengthening scheme for deficient or for the vulnerable masonry structures. So I will take you through some of the case studies which we have done recently. And as Dr. Sushant has also mentioned about the Nalanda, so this is one of the study which we have recently completed on the Nalanda Mahavihara. So this is called to be the oldest and the biggest university in the ancient time in the world. So it is believed that this could be the one of the first residential university in the world, which was almost about 2000 years ago. So this is one of the site of the Nalanda Mahavihara. It is distributed in almost 50 acres, and this is one of the popular site which was found after the excavation. So what we did, this Nalanda Mahavihara, and this figure shows the complete site map. So almost 58 acres. There are multiple sites. So till now, Archaeological Survey of India has unearthed about to 12 to 13 sites at this place, and it is good to see. Those who love masonry, they should uh, at least visit this place once. You will see how delicate or how complicated masonry construction is done during the ancient times. So what we did, so we got permission from ASI, collected some materials from the site. So we collected some brick samples, collected some mortar samples, and then these samples were properly washed. They were cut. The mortar samples were ground into powder and passed through a fine sieve of 75 micron. And then one can perform some of these tests. If the brick size, if you get a good size of a bricks, you can cut them into the small pieces and use them for the different tests, like for density, for water absorption, for compressive strength, and for tensile strength also. And the mortar samples can be used to find out the binder aggregate ratio so that we can recreate those mortars in the lab. So to find out the binder aggregate ratio, there are some simple tests. One of the tests which is very popularly used, which we call as the acid digestion. So the concept is simple. So in the acid digestion, what will happen? So whatever the material which is inert, it will not dissolved in the acid, whereas the binder, which primarily consists of a lime, it will get dissolved in the acid. So there are some specialized equipment and some simple chemicals like SCl you can use. And by using this test, you can find out that how much is the proportion of a binder and the aggregate. So this is how it can be done. Either you can do it simple acid digestion, or you can also use a microwave digestion system also to get the results much quicker. So this is how the process is. There are some a particular size of a filter papers which has to be used uh, to segregate the insoluble aggregates. So what we find out that especially the render, the plaster which is used at this Nalanda Mahavira, so it has a very high content for binder. So binder to aggregate ratio, you can see we found out almost a ratio of 1:1. Okay. And that could be the reason that why these structures are still durable and they have not seen much deterioration with time. And then one can also do detailed characterization. One can know about the microstructural features of materials, so such as for the bricks. So this is the SEM test for the brick. So bricks are coated with some metallic uh, material. So the gold or a silver is more popularly used so that you can get a good reflective surfaces. And using this SEM, one can know about the composition, one can know about what are the various minerals which have been used for the construction of these bricks or for the manufacturing of these bricks. And you can also know about what could be the firing temperature during that time. And it was interesting. We have seen that even during that time, the bricks have been properly made in the furnaces, in the brick kilns, and the firing temperature for those bricks were also close to 900 to 1000 degrees centigrade. So this is another test which one can also do, X-ray diffraction, again to know in more detail about the minerals and also to know about the type of soil used for preparation of those bricks. Again, the firing temperature also. And these are how you will get the signature, a typical XRD profile, how it looks like. And one can also know about the various details about the material composition during that ancient used in these ancient structures. So as I said that we found out the mortar which is used commonly for the render for the plaster is a lime mortar consisting only of the lime as a binder with some mica mineral and the aggregates are primarily the siliceous aggregates. The firing temperature has been found for the bricks to be more than 950 and but less than 1050. So it was in the range of 950 to 1050 degrees centigrade. So it shows, so it was, so scientifically we were able to prove what kind of a manufacturing technique, what compositions have been used in those ancient structures, specifically in the Nalanda Mahavira or Nalanda University. I'm not going to detail of those. It will take a lot of time. So this is one of the case study which has been done. Another test which can also be used, which is thermogravimetric analysis, TGA. So this will also help in determining certain properties. Again, the firing temperature, some presence of whether there could be some organic materials present in the mortar or in the brick elements. So different tests one can do to find out the type of a material used for the construction of these ancient or these old masonry structures. We also did a particle size distribution because to recreate the mortar, you should know the size of the particle size distribution of the aggregates. So we also did using hydrometer or using some advanced equipment like laser scattering particle size analyzer. Uh, Interestingly, another thing what we find out that for the bed joint in those times they were primarily using the mud mortar. So this is the sample of a mud mortar which has been taken from that site, and this is how the particle size distribution of this mud mortar looks like. So primarily consisting of a silt and some part of a clay and sand. So in summary, for this case study, so we were able to evaluate the various type of materials and these materials. So now the next part, what we were doing right now is we have now recreated this masonry, the Asian masonry in our lab, and then trying to find out what could be the properties, like the elastic properties, like the compressive properties or the shear strength properties, and then to know more in-depth knowledge about these structures, that how they could have been designed, how the proportions, how the sizes of these structures have been evaluated, and what is the good thing which we can learn from these ancient structures and which we can incorporate in our modern design and modern construction practice. Now, many engineers and researchers, they used to ask that what kind of a in situ testing we can do for masonry to find out the strength parameter like shear strength or a compressive strength. And many misconception is to use the rebound hammer in UPB. So we have seen many consultant who claim themselves as uh, evaluating the masonry structures, evaluating the old masonry structures. So they use rebound hammer, but using rebound hammer directly for masonry structure is not applicable. You cannot use them because whatever the rebound hammer which are available, so they are mostly calibrated only for a concrete. So you have to either calibrate it for a particular type of a bricks, or you need to test lot of bricks and then find out some kind of a calibration curve that if the rebound values are these, and this can interpret it to a this much of a brick strength. So lot of data has to be collected, and the rebound hammer has to be calibrated for masonry structures. But the challenging thing is that you can only know the strength of a brick. You cannot know the strength of a masonry. For that, you need to also find out the strength of a mortar and then using some equations. So right now, we are also doing some work, and some work has been already done in Europe recently, where using the rebound hammer, you can find out the strength of a brick, and using some tests such as like a pull-out test, you can find out the strength of a mortar, and using some analytical equation, then you can find out the strength of a masonry. UPV, so all these tests directly, they are not applicable. So if somebody is using or recommending, so please do not use the conventional UPV and conventional rebound for finding out the strength of masonry. So the test which can be done. So first test which is called as a flat jack test. In India till now, we do not have a IS standard on this. You can follow the ASTM standard. So this is called as a flat jack test. So what is done in the flat jack? So we cut a slit. So we remove a mortar from some part and then insert these plates. What the plates you can see here. So these plates are primarily a thin jacks. So these are a hollow plates where the oil will be pumped inside. So these you can put the two plates, one at the top, one at the bottom, and then apply the pressure. And then you can put some sensors or a dial gauges to measure the deformation. So this test can give you the compressive strength, can give you the elastic modulus of the masonry present at the side. So this is a very good test. Of course, slightly difficult to do. So you have to cut the slot and then you have to insert these flat jacks, and these flat jacks can only be used not more than 3-4 times, because when they get inflated and due to the permanent deformation, you cannot reuse them again and again. So these are some of the components. So these are the flat jacks. It comes in a different shapes depending upon the type of masonry, type of based on the requirement. You will need a hydraulic pump. This is a hydraulic ram, which is used for another test. I will show you that. And then the dial gauges, then these are the splitters. And if suppose your slots are bigger, then you can put the steel shims to fill those bigger slots. So these are some of the photographs which recently we have done one assessment along with the state government of Bihar. So cutting the slots, you can see here how the slots were cut, then inserting these flat jacks, placing the dial gauges. So this is how the dial gauges has been placed, and then applying the pressure. And then after the testing, you can seal it and nobody will know you have done some test there. So the previous test, flat jack test, which can give you primarily the compressive strength and also the elastic modulus, which is required for the designing, which is required for the modeling purpose. The next test which you can use, which is quite important, especially for the seismic evaluation, is the shear strength test. So the in situ shear strength, it can be find out using a test which is called as a Shove test. So what we do in this test, that you can see here, we remove one brick from this end and another brick from uh, the behind. So you can see the pressure jack is placed here, and then we have the middle brick is pushed. So at whatever the force, this brick will slide. So that force, you can call it as a shear strength or a sliding capacity of a masonry. So this is also a simple test which can be done easily. So here are some photographs you can see here. So one half brick is removed here and one slot is created here. So at one place you can put a dial gauge to note down the slip, to note down the deformations. And then this small jack is placed to push this middle brick. So this is one of the tests we have done for a couple of buildings, about 10-15 buildings we have done. I'm just showing you results of 3 buildings. So in one of the building, we found that the shear strength is very, very low, 0.08. And if you remember, I gave you a number of 0.1 as per IS 15988. And then we did also detail assessment, and we found that this building was unsafe for resisting the earthquake forces. Whereas for the other 2 buildings, the shear strength was quite optimum, quite good, 0.66, 0.4. And we were also able to find out the average compressive strength, 2.5, 2 MPa, the modulus. So this is how you can find out, or you can get from all these testing. So this is another major issue which has been seen in India. If you will see in the major part of India, especially in the western part, in the northwestern part, sorry, this eastern part, northeastern part. So you will see that in majority of these states, we have also seen a use of a reinforced brick slab. Now these reinforced brick slabs, they have been deteriorating quite fast. And there are a couple of requests at I can say that many requests we used to get, that how we can assess whether these reinforced brick slab are safe or not. If it has to be retrofitted, then how much it had to be retrofitted. And after retrofitting, whether it is safe, or how we can see whether the strengthened slab is meeting the all acceptability criteria or not. So for this, you can also do you can do a slab test. So what we did for okay, requesting all of you to kindly mute yourself. I can see some noise. I can hear some noise.
Yes, sir. Please go ahead, sir. I'm muted.
Yeah, thank you. Okay, so another test which can be done for the slab, which is the slab load test, it can be done as per IS 456, or you can also refer to ACI 357. So in this test, simply the sandbags are kept over the existing slab. So I can show, yes. So this is a picture. So where these sandbags were used to load the slab, and then you can put the deflectometers from the bottom, or the displacement gauge, and you can find out that how much is the deformation, how much is the displacement. You have to load the slab in some kind of a small interval, or small loading interval, and then keep on noting the deformations. And after 100% of loading, leave the load for 24 hours, and then you start unloading. And after unloading, you have to see that whether the displacement which has been noted during the full load, and how much displacement has been recovered. So the code says that if 80% displacement is recovered, which means that the slab is good slab, or has been meeting the acceptability criteria. So these are all various tests which you can do to find out, or to evaluate the strength of your existing building. So we have seen about uh, the test to find out the compressive strength, test to find out the shear strength, especially for the masonry walls, and then to find out the integrity of the slabs. If you have a reinforced brick slab, or these tests are applicable for any type of slabs also. So then the question comes, with the researchers, students, and engineers are that what we should do with these values if we know the strength parameters. So one thing which you can do simple calculation. If you have a strength with you, so you go back to simple equations, find out what is the total shear demand of your building, and divide it by the capacity. So if that demand capacity ratio, if it comes less than 1, which means that your building is safe, it does not require any strengthening. But if the demand to capacity ratio, if it is coming more than 1, then of course it means that some strengthening is required for those buildings. So to perform detailed analysis, in some cases, these simple calculations are not possible because we do not know that how much mass is participating in the first mode, in the second mode, or you are not sure whether the which wall will be participating, or if you want to know in more detail about the the performance of a building, then of course you can take a help of various tools. Numerical investigation you can do. There are a lot of new analysis techniques which are now available, which are upcoming. So one of them is the numerical analysis using various modeling methods. So I am starting with a more complicated one, which we call as a micro modeling, where we try to model each brick and mortar. And by using these kind of a modeling, you can also know about the local failure. You can understand that how the wall will collapse, how the building will collapse, which element will fail first, and you can know about the various minute details about the performance of a building. However, such modeling techniques are quite cumbersome. It takes times, and also you need a good computational uh, resources for analysis of such kind of uh, buildings which are modeled using micro modeling technique. So next method, a simplified one, which many researchers used, many engineers also used to go with the simple macro modeling technique, where we simply model the wall as a continuum element, a composite element, and then define properties, compressive properties, tensile properties. But the limitation of this methodology, of course, it is that you cannot know about the localized concentration of forces, stresses. You cannot know about the cracking pattern. Of course, indirectly, one can know about cracking pattern using the plastic strain contours. And also, you will not be knowing about the various interface behavior, whether the failure will be a sliding failure or a diagonal shear failure. So it is difficult to assess those minor details from the macro modeling. So this is one of the finite element analysis which we have done for a building, school building. So where we have developed the complete model of a school building, and we want to assess whether what will be the contribution for different seismic bands. So you can see here there are seismic band at different locations, at different locations along the height of a wall. So we want to understand whether the one seismic band is sufficient, two seismic bending is sufficient. So did detailed analysis, nonlinear dynamic analysis, incremental analysis to find out the fragility curves for these school buildings, which are very popularly used in hilly areas. So these are the tools which you can use. You can find out. Uh, this is how you can see the strain contours, the plastic strain contours. So you can see that some of the walls might be facing a diagonal failure. There can be out-of-plane failure of some of the walls. So all these information, you can see there are the high strain, plastic strain near the openings. So opening need to have a proper confinement. So all these information one can gather, and one can find out that what could be the common failure. There are some questions coming in the chat box, so I will answer those after finishing the presentation. It is good you keep on writing whatever the questions you have. So these are the common failures which one can understand, which one can evaluate by using these modeling techniques. So for micro model, there are some advantages, but there are some limitation. For a macro model also, there are some advantages, there are some limitations. So what we did recently, seeing the demand that how the buildings can be evaluated and how one can get more better understanding of the responses. So recently, we have developed this macro discrete element method. So in the macro discrete element method, so instead of modeling the building brick by brick or a stone by stone, you can divide any wall into just these 6 elements: 1, 2, 3, 4, 5, and 6. Okay, so these 6 element has been decided based on that what could be the maximum possible failure modes of any masonry wall. So it can have a diagonal failure, it can have a out of plane failure, it can have a sliding failure. So based on these, so we have come up with this simple scheme where you can divide the walls in these 6 big blocks instead of dividing them into the small blocks. Then of course you have to assign the interaction properties, because all these blocks will be having some interaction properties. There will be a sliding, there will be a cohesive properties. So we did a lot of experiment and then proposed that what could be the interaction response at different locations. For a horizontal one, for a diagonal line, for a vertical line. So different interaction properties has been suggested. You can you can go to my website or go to my Google Scholar. Recently, the paper has been published also in engineering structures. You can know more detail about various interaction properties. So this advantage with the macro discrete is that you will be able to simulate all different failures, such as sliding failure, the crushing failure at the corner, the diagonal shear failure. Uh, you can simulate also the outer plane failure. So in this case, you can have cracking. So these red color lines are showing the possible failure, possible cracking line. You can have, if there is a two-way bending, you can also be able to simulate the two-way bending failure. So those are the numerical analysis. And then I will conclude my presentation with another case study, which we have done when I was in IIT Kanpur on a Lucknow monument. So where you will see that how starting from a first step of a material characterization, evaluation, and how the numerical analysis can be used for the assessment. So if you are from Lucknow or if you have visited Lucknow, then Lucknow is having these Imambara complex, which were done somewhere about 300 years ago, and a lot of typical Mughal construction you will see there, with arches, with the domes. So this is one of the structure which is Rumi Darwaja. Rumi Darwaja, it is kind of a gateway entrance to this place, the historical place. So we were interested to evaluate the performance of this Rumi Darwaja, this complex, because there were some cracks which were getting developed in the dome, in the top part of a dome. So we were quite excited to see that how we can evaluate this monument, this particularly this gate, this gateway. So what we did, we did some initial investigation, did a site visit, and we found out that the bricks which have been typically used are of a small size. A typical size is equal to your size of a palm. So 100 by 80 and the thickness is 20 mm. But the thickness of a mortar is quite large. So this is completely different from what we have find out in Nalanda. So Nalanda will have a typical brick, a thick brick, a bigger brick, but will having a very thin mortar thickness not more than 3-4 mm. Whereas in these monuments, especially in the Mughal, the monuments of the Mughal era, so these are totally different. They are having a thin brick but a thicker mortar. So these are some damages which have been seen. So we want to evaluate this historical structure. So started with the material collection. So we collected the material. Material characterization was done. Simulated the mortar, find out the aggregate binder aggregate ratio, and then did the seismic evaluation of that dome. So these are the properties of a brick. So brick samples were collected. So you can see the density, water absorptions were quite good, which shows that the bricks were of a good quality, and they were having a quite significant strength, about 20 MPa, 18 to 25 MPa. Then move to the material characterization to know more about the bricks, what are the compositions, compare them with the contemporary bricks which are available these days. So we found out that the bricks in the Mughal era and the bricks which we currently use, they are nearly same. There is not much difference. In binder aggregate ratio, we found the binder aggregate, it is a lime mortar, lime rich mortar. So about the ratio is found to be 1.1 to 1.8 to 2.9. So about 1.5 to 2.5 times lime binder to aggregate ratio we have seen. So then using those uh, properties of a bricks and using the properties of a lime, so we recreated the lime in the lab and then developed some specimens. So first specimen is a stack bond prism, then the multi-wide prism, and then the masonry wallets for the finding out the tensile strength or a shear strength. So we formulated the masonry, finding out the mechanical property using the stack bond prism and the multi-wide prism, then the elastic modulus, and then the diagonal tensile strength. So this is the first test. So 5-brick prism test. So this is the small specimen of a 5-brick prism. And then these are, because these walls are having a multiple layer of a brick, so we also did a multi-wide specimen. So specimen size is 290 by 290 by 400. And this is what the results have been found out. For the masonry, the strength was 3.5 MPa. Modulus was quite low, 315. So it shows that the lime mortar provides a low plasticity or the low modulus, which is good, which you can also say that that is why these structures are standing till days. They were able to uh, absorb various earthquake shaking. The multi-wide prism, as expected, it is having a lower strength, 2.09 MPa, 2.1 MPa, and also the lower modulus. And then we also compared the results with our traditional or the contemporary masonry. So you can see, so this is the blue color line. This is the historical masonry. So you can see that the historical masonry, the response is quite soft. So which also shows that they are quite flexible. Whereas the conventional masonry, which we have, even the weaker one, is having a higher, significantly higher elastic modulus compared to the historical masonry. So one can also say that this could be a reason that why these older masonry structures are still standing. They have not experienced much damage in last 1,000 years or 300 years or 500 years. So low modulus of elasticity and higher nonlinearity reveals that historical masonry have more deformation and more plastic capacity. This is a diagonal compression test, which is commonly used to find out the shear strength or a tensile strength. The shear strength was found to be 0.11 MPa. So 0.11 MPa found to be quite low for these type of masonry. So you just remember this number 0.11, we will see in the analysis part. And the tensile strength is approximately, you can say 3% of a compressive strength. And then after finding out the properties, we have the elastic modulus, we have compressive strength. Then the finite element analysis was created. So we did both 2D and the 3D analysis, where we performed the pushover analysis, modal analysis, and also we did the response spectrum analysis to find out the seismic demand and capacity. So the pushover analysis was done in a simpler way. So this is a 2D arch, and this is what the pushover curve has been found out. So one can see, so up at about a drift of 0.4%, this uh, dome or this arch has reached a peak capacity, which is about 17% of its weight. So the seismic capacity, if you put it in terms of a weight, it gives a better interpretation, better understanding about its capacity. So it was found to be 17% approximately. And using this pushover analysis, we also identified that what could be the possible failure zones. So the 4 hinges have been found out, two at the supports and one at the interdose, one at the extra dose. So this is the common failure of an arch. You will need at least 4 hinges for the failure of this system. So these are the 4 locations. And then did a model analysis to find out the frequency, comparing the 2D and 3D. Of course, 3D will give you more stiffer response. So 3D time periods or the periods will be much lesser compared to a 2D one. And then using the response spectrum analysis, assigning Lucknow lies in zone 3. So this is the older one, older IS 1893. And using this response spectrum analysis, SRSS rule for combination. So this is how the results of a response spectrum analysis looks like. So as you can see here, the tensile stresses are coming more than the capacity. So if you remember from the test, we got a tensile strength of 0.11 MPa, whereas it has been found out from response spectrum analysis that the tensile stresses at many location is exceeding the limb capacity. So it is 0.41, 0.38. So this is close to the capacity. And in also in one of the direction, uh, the demand, which is the seismic weight demand, is more than the pushover capacity which have been found out. So pushover capacity, if you remember, the capacity was found out to be 17, but here in one direction it was found to be 21, 21.8, 22. So the tensile stress exceed the demands. The base shear of 21.8% of its seismic weight in the plane of arch is the critical for the earthquake, and that is why there has been some damage in the structure because its capacity has been reduced by time, and it is required that it has to be retrofitted or strengthened. So again, the summary of this case study that we were able to do the complete understanding of this project. So starting from a material characterization to seismic evaluation using the numerical analysis based on the properties which has been obtained from the test, and then using those properties to find out uh, the possible failure to find out whether the strengthening of this structure is required or not. So, so that is all from my side for today. So I thanks my collaborator, my supervisor there at that time, Professor Rai. And then this Nalanda project we did in collaboration with IIT Bombay, Professor Swati Manohar, and my PhD students who helped in this project. And the funding agency, Bihar State Disaster Management Authority, and DST. So it involves two projects. So these are all basic things which you can learn and how you can uh, try to evaluate your structure in a more scientific way instead of using a rewound hammer or UPV, which are not generally applicable. So this is how a complete evaluation of a old masonry structure can be done. So so this is all from my side. So thank you so much. Let me see what are the questions and
Yes, sir.
then
Thank you, sir. Thank you, sir.
yeah.
Very informative sessions, and you showed a lot of in situ testing methods and the case studies, and it is definitely will be helpful for our participants.
Yes, let me take the questions from the chat box. Okay. Okay, so what software is used for FE analysis? So it is up to you. You can use any software. So we use here commonly Abacus. You can use ANSYS also. Any general purpose software can be used. Of course, it cannot be done using your structure analysis software like SAP or StatPro. So those software are not capable of having those simulations. So Abacus, ANSYS, and there are some other softwares which can be used. Again,
So
which
for
software
pushover
used for
analysis also,
micro?
sir, you use the abacus.
Yes, for pushover also we use Abacus. Nowadays in SAP you can use SAP also. Now SAP also have 2D elements with nonlinear properties. So the problem is that most of the softwares, especially the commercial software for structure analysis, they do not have for a plate element or 2D element nonlinear properties. For
Mm-hmm.
beam element, column or beam, you can assign the hinges, you can do the pushover analysis. But for these plate type of structures, you have to use either Abacus or ANSYS.
Yes. Yes.
One candidate is asking plexes. Yes, plexes can be used, but it is primarily for soil for foundation part. So you may not get some a constitutive model which are used for concrete or for masonry. But yes, it is possible. You have to find out the correct constitutive model. But I am not sure. I have not used plexes. Our colleagues in geotech, they used to use plexes, but mostly for understanding the soil structure interaction and also understanding the soil behavior.
Yeah, so far, I know, sir, Plaxis is being used by the geotech applications.
Yes, yes. Only mostly geotech application. One question is regarding flat check test. Up to what limit test will be carried out for compression? If building got crack while testing, how we can rectify? So it seems you have a bad experience with flat check. Hmm? So it is up to you. See, you have to monitor it carefully. You have to see. So whenever, if suppose you have a doubt that the masonry is too weak and it can fail, so I can share the experience. So what happened in one of the building, it was not in very good condition. So when we were doing the flat check test, what is happening that when we're cutting the slot, so the bricks above the slot are getting collapsed and the masonry is too weak. So then we decided not to do a flat check test for that particular building. We only did the shear test. Now, up to what limit you can apply the compression? So what you can do, you can monitor it. So what we used to do that we apply a small compression, take the reading of a displacement, again apply the small compression, and we also used to put some small load cell uh, connected to the pressure check, or you can even calibrate the value of a pressure to the load and find out whether your load is getting constant or the load is increasing further by applying the pressure. So as soon as you see that the load is not further increasing, you should stop the test immediately. And you can then say that the compression capacity has been reached. Uh, and you can stop the test there. But of course, if suppose you are seeing some crack, then immediately the test has to be stopped. And rectification, there are various methods you can use it for rectification. First of all, if it is getting cracked, then definitely it shows that the building is not in a healthy state. And retrofitting can be done by epoxy injection, fill those cracks, and then use some kind of external reinforcement for strengthening of that building.
Sir,
Slide number 39. Some
Hello,
question.
hello, sir. Am I audible, sir?
Yes, yes, clearly audible.
Yes, sir. I have a little bit doubt in slide 39. Could you please again share the?
Yes, sharing slide.
Sir, this is, sir. I have a doubt that this is the wall, sir. I think you have divided into 6 elements, huh?
6 elements, yes.
Yeah, sir. Each element is the bigger one, or each element again you are dividing into smaller elements like we usually do in finite element analysis.
No, no, these are the bigger blocks, only 6 elements. It is not further divided. So each element will be having a property of a masonry. Whatever the properties you
Yeah.
will get, elastic modulus or compressive properties, tensile properties, and then the
Yes, sir.
interaction will be defined. So it is
Sir,
just to
then
simplify it. Yeah.
yes, sir. But how, sir? Means what about the joint, sir? Interface, because masonry is a combination of brick and mortar, right? So how is the element you are deciding between the interface of brick and mortar, sir, in these bigger elements?
So that is what I am saying, that we are not considering here brick the interfaces between the brick and the mortar. So if you
Yes,
want,
sir.
if you are interested in that, then you have to go with the micro modeling. Okay. So I have shown you, see, there are, first
Yes,
is
sir.
your if you go to this one where we are modeling each brick or each stone and also modeling the mortar. So this is
Yes.
quite cumbersome. So suppose if you're modeling a complete wall, so in one wall you can have 400, 500 bricks defining the interaction properties, modeling the mortar, it becomes
Yes, sir.
difficult and it cannot run in your computer. You need a bigger workstation or some kind of a supercomputer to run it. Other option
Yes.
is that you simply model it like a single unit, a single composite. Okay.
Yes,
But
sir.
the problem with the single composite is that you cannot see the failures, typical failures, right? So
Yes, sir.
that is
Yes.
what
That means
we
the where the
suggested.
actually the stress are concentrated exactly at what point that
Yes,
cannot be
yes,
found out in macro blocks,
yes.
like.
Yes, that cannot be find out in this one, macro one. Now
Yes,
in
sir.
this, when you divide into 6 so these 6 blocks are divided based on the experience that what could be the possible failure. Okay. So
Okay, sir.
that is what I have shown here, that possible failures can be sliding, right? It can be a crushing of the corners. It can be a
Yes, sir.
diagonal failure. It can be the
Yes, sir.
outer plane failure, or it can be a two-way bending type failure. So based on all these understanding, we say that instead of doing brick by brick, if you
Yes,
do
sir.
by this method, having a macro blocks, then you
Yes, sir.
will be able to get a better understanding of a failure. You will be able to see some kind of a cracks, how the cracks will propagate, how the wall will fail, whether the wall will be having a shear dominant failure or a flexure dominant failure or a
Yes.
sliding failure. So those informations you can get. I'm not saying this is perfectly accurate. More
Yes, sir.
accurate results you may get from a micro one. But the
Yes.
challenge with the micro is that modeling is difficult and running it
Modeling
also
is
it is
different.
difficult.
Yes.
Yes.
Yes. So can anyway this micro and macro can be related, because by doing this macro analysis, can we predict the micro level failures? No.
By
Anyway,
using this
connections.
six
Yes.
blocks
Yes.
type.
Yes. Yes, sir.
You can do. That is what we have also tried. We have done for the 3D building also, where you
Yes,
can
sir.
even see the separation of a walls. Because at we used to model those blocks separately. You can do see the separation. So it is actually your requirement whether you want to see the global failure or you want to see the micro level failure of a various element. If you are interested in seeing the micro level, then definitely you have to go with the micro analysis. You have to model each brick or unit mortar separately. So it is up to your uh, requirement. Okay. So we have
Mm,
tried to give a midway that if you want to see the failure, if you want to understand the interaction, understand the various possible failures of a masonry wall of your building, then you can go
yes,
with
sir.
this macro block.
Okay, sir. Thank you, sir. Thank you,
Okay.
sir. Thank you.
Okay.
Sir, in continuation of this question, say one wall is there and we
Okay.
have kept window as a opening and I am doing the macro
Right.
modeling. So
Yes.
whether I can capture the diagonal shear failure at the corners of the openings in macro model?
Yes.
You are saying about the macro block or only macro?
No, if I do the macro model instead of micro model, if I do the macro model, so if I model one wall and
Macro,
it's with, yes,
this
yes,
one.
yes, yes.
See,
So if I
you
keep
will
one
get in.
opening in between, yeah.
If there is an opening, so
Hmm.
you will not see physically the cracks there because you're having a single unit. So what generally we do, we used to see the values of a plastic strain, where the strains are getting maximum. So there can be the possible location of the cracks. So when you do a opening, you do the analysis. So from the corner of a opening, you will see those plastic strains, higher plastic strains, which shows that those could be the possible failure planes.
Yes, yes, yes. Participant, if you have any questions, you may ask. Sir, I have one question, sir. Just while showing your
Yeah.
presentation, so you showed the flat jack test.
Yes.
Sir, another popular in situ testing is the masonry code testing. So for the compressions and all those for masonry code testing also they do. What do you suggest? Means which one give the more reliable results?
See, masonry core testing is becoming popular, but still it is not standardized. Rylum is working on standardizing that core testing of a masonry. But if somebody is using, then please use it carefully because what will be the problem with the masonry core is that the results will be highly dependent on the location of a joint, whether the joint is coming parallel to the core, joint is coming perpendicular to the core, or it is at some other angle. So right now, detailed work is going on. There is a special committee formed with the RILEM. So where are researchers from different universities, they are working on to standardize this core testing for masonry. But right now it has not been standardized.
Yeah.
So you cannot have a correct assessment using that.
Yes,
So
sir.
that
I'm
is
happy
why,
to be with this, sir. I'm also part of that committee, actually.
great, great.
Actually, they
So
are doing
I
the
have
round
seen,
robin tasting, and actually,
yeah,
what they want, sir, here in India, the unit strength is less as compared to their side, their country.
correct.
So that for that reason, what is the variation of the results are coming? So that's also part of the content, but it will take time. At least 5 years time has been given.
Yes, yes, yes. It is good. Good. You are able to contribute to that committee also. Great.
Yeah, yes, sir. Yes, sir. Any more questions from the participant? You may ask. You may unmute yourself and please ask.
You can ask anything.
Sir, I
Don't be shy. But if you
as of
want
now there is
to,
no questions.
uh,
Sir,
yeah,
one more question I am having, sir. Uh,
yes,
Yeah, you showed the Lucknow monument, that one, and so far I
yes,
remember when I read that paper, it was
mhm,
mentioned like it was for repairing and all those. If the motor is not compatible, so it will not work. So we have to
yes,
find out the motor sample, collect the motor sample. We have to prepare the compatible motor. So while
correct, correct.
preparing this compatible motor, what are the things to be remembered? Like we have to do the microstructure study so that we can know the component and all those. What are the things has been mixed, lime-based mortars, and apart from that, from the unit or brick point of view, what should we think? Means we should. What are the points we should consider?
No, as you have rightly said, so what we have seen also in the Lucknow monument, so at that time ASI was not using the correct
Audible,
proportions,
sir?
and
Hello,
yes, yes, you are audible. I am audible. Hello.
am I audible, sir?
Yes, you are audible to me. Can you hear me? Hello. Hello.
Yes, sir, you're audible. Sir, you're audible.
Okay. Okay. I think
Yes, sir.
Susanta, you cannot hear me.
Yes, yes,
Can,
yes, sir. Yeah.
okay. I heard your question. So your question was related to the compatibility of a motor.
Yes.
So what we have seen in most of the monuments when they do the restoration work, so many times they don't do the characterization of these Asian material, and they use some other different type of materials, which can lead to the further deterioration of the older material. So what happens, that material characterization is one part which is important, and we have also seen that it is also important to know about the particle size distribution, because what is happening that if you use very fine aggregate or very fine mortar for the restoration purpose, then it can block, or it will not allow the breathing of these old masonry structures, and which can lead to the further deterioration. So w- uh, the few things which you have to see, which you have to keep in mind while doing the restoration, that material should be compatible in the sense of the material composition should be nearly similar to what has been used in the ancient time. And to find out the material composition, you can do all these tests what I have shown, acid digestion or these XRD test or SEM, to find out the various composition. And also you have to see that the grade of a material or the gradation of a material has to be matched closely, so that the actual state of a material, actual state of a structure of a wall can be maintained, so that it should allow the sufficient breathing, sufficient evaporation of a moisture, ingress of a moisture, and all these things. So these are also becoming now very critical for in a restoration purpose.
Okay, sir. Thank you.
Thank you so much.
Is there any questions from the participants? I don't think so. Thank you, sir. Thank you for sparing your time with us, sir, and accepting our invitation.
Thank you. Thank you so much. And if any participant have any question, you can also send me an email. You can get my contact number or email from Dr. Banerjee. Please feel free to contact.
Yeah. Thank you, sir. Sir, would like to present you a small token of thanks, sir, from our
Yes,
side.
thank
Please
you.
accept.
Thank you. Thank you. I accept it wholeheartedly. Thank you so much for inviting me